I think I'm live. I'm acting live. Looks like I'm up and cooking. Hi, everybody. It's Mike Meyers. Yay! Do. Just take a look, see who's here today. Okay, so I guess I'm alive. JD. Hey, JD. Andre, good to see you, brother. Virgil, let's go. And on that day, Virgil Grissom was the greatest pilot ever. Patricia Grace is here. Fantastic. All right. Well, everybody, welcome to the Mike's AMA. Today we're going to be talking about routing tables. It surprises me how little people understand about routing tables. I mean, it's like literally the cornerstone of what makes the internet go. And without them, well, just things are dull. So what I thought we could do today is take some time and talk about routing tables. And let's see if we have some good understanding of routing tables and how they work. I'm going to try something real quick. All right, so let's just go ahead and take a second. And let's first talk about, make sure we understand some basic rules here. Do we understand why routing tables exist? Every host device on a TCP IP network has a routing table built into it. And it's the routing tables that are the primary tools that... I'm sorry, I was looking at JD's explaining Jean Doridal. Hey, Nigel Hunt, man. Good to see you too. LaRose, okay. So anyway, routing tables exist everywhere. I have a routing table in this phone. My cameras have routing tables in it. Everything has a routing table. So what I want to do is let's start off by just taking a look at a very basic routing table. We're going to take a look at the one that's here is on my host machine. But before I bring that up, I want to make sure you guys have a little peek as to what do we have going on here. So let me bring up my control panel. Let you guys take a look at this. All right, here's my control panel. I'm going to make it big so you guys can't see the terrible mess underneath there. Let's go to networking and sharing center. And what we're going to do here is we're going to go into, let's take a look at the different types of adapters. So what you're seeing right now, folks, is I have one Ethernet connection. That's it, okay? And then I got a virtual box connection. And I don't want to turn that, can I turn that off? Sure, let me go ahead and turn that off for right now. So what I've done here, folks, is I have exactly one type of connection, a typical Ethernet connection. So what I want us to do is let's go ahead and look at the routing table on this particular host system, and let's look at about the most simple routing table you can get is a routing table for an individual system with one network card. So let's go ahead and bring that up. So the best way to do that is, what am I going to use here? I guess we could just PowerShell this. All right, so back to the old PowerShell here. And what I'm going to do is I'm going to type in, there's a number of commands to do this. At the command line in Windows, we tend to use route print, which is the most common way to look at the routing table. So route print plus, that's an A plus and a network plus question, so you should know that. So the first thing that Windows does is it lists all of the devices that it sees, okay? And then on top of that, it then gives it an interface link, all right? So right now, hopefully the only thing we should be seeing right now is this Ethernet connection, which is going to be link 14. All right, so Down here, this is going to be a IPv6 routing table. For now, we're going to ignore that, okay? And what I want to do instead is just concentrate on this right here. This is a traditional routing table. Let's see, can I make this a little bit bigger so you guys can see it a little bit better? There we go. All right, so this is the part that I'm interested in seeing. So what I want you guys to look at here more than anything else is, first of all, the IP address for my network card on this machine is 172.18.13.120, all right? I know that because I configured it. When you're looking at a routing table, the first and most important thing you got to do is, each one of these is a route, okay? But the first and most important thing you got used to saying is, get ready, say this. Whenever you read one line, say, unless, and then you go to the next line, okay? So let me show you how this works. So what you're looking at here is, whenever you see zeros, it means I don't care, and whenever you see 255s, it means it has to absolutely match that. So this first route is a very important route, folks. Read this carefully. I don't care where it's going, and I don't care what the subnet mask is. No matter what it is, send it all out through the router, through my network card. Do you get that? This is the default route, and the default routes are a cornerstone of all routing tables. Look, you've got to have some way to tell your system, if I don't specifically have a route for this, here's what I want you to do with it. So default routes are important, and they always pretty much look like this. We're going to see all zeros like that. Let's just keep going though. All right, so that's my default route. Let's read it one more time. I don't care where it's going. I don't care what its subnet mask is. Send it out on 172.18.13.1. That is the LAN side of my router, people. Send it out and send it out through my network card. The metric, we'll talk about that in a minute, okay? So that is my default routing table. Now, at the end, unless you say, unless, you could also say except. Unless it's for the network 127, I don't care, as long as it starts with a 127 and it's a class A and the gateway is on link. Gateway means just use the network card. That's all that means. Don't send it to an upstream router, just send it to the network card. So this is the 127.0.0. Now we all know that 127.0.0.1 is the loopback address, right? Well, if you read what this thing is saying, let's look at it together one more time. If you read what it's saying, it says, if it begins with the 127, I don't care. Remember, that's what zeros mean. I don't care what the rest of it means. As long as the first net mask is 127, I don't care what the rest of it is, send it out on my loopback interface. It didn't say 127.0.0.1, folks. It said anything with 127. So this could be kind of interesting. Want to have a little fun? So theoretically, I can ping anything and starting with 127, and it'll ping the loopback. Let's give it a try. All right, so I'm going to just ping 127.23.24.25. Whoops, I got a typo in there. All right, now according to the routing table, this should work. So I get a response, which is interesting enough. I get a response from an address 127.23.24.1. It's just as though I did, here, let's do a classic 127.0.0.1. We all know and love this one, right? Oops, don't put double zeros in there. And now we get a reply from the loopback, just the way we would expect. So basically what you just saw here, and this has been built into every Windows routing table since, well, God was a teenager. Basically, the loopback of 127.0.0.1 ain't true. If you start anything with 127, it goes to the loopback because of your routing table. Interesting, huh? Let me get my screen cleared here. We'll do another route print. get that back up there so you guys can see it. Okay, let's take a look and see what else is in a routing table. All right, so here's the routing we just expected. If anything that's 127.0.0.1, it has to be exactly 127.0.0.1, just ping to 127.0.0.1. Okay, that one makes more sense. And here's the one that says 127.255.255.255, and if it's exactly 127.255.255.255, set it to 127.0.0.1. You start thinking to yourself, it's like, do we even need that line? Do we really need a line that says 127.255.255.255? So basically what you're seeing here, folks, are these are broadcasts. And so you do kind of need them. So really the only 127 we'd expect to see would be 127.0.0.1, and then the net mask would be all 255s because it has to be 127.0.0.1, but it's not. We can type 127. anything, it's treated like a loopback. It's because of the routing tables. Every Windows routing table is going to have those three 127s in there, no exception. Pretty much all the Linux ones do too. Because that's just how it is, man. All right, so we can make this a little bit more fun. Let's go back in, and this time we're going to be skipping the 127, but let's talk about, you keep in mind, on our network, I've got a 172.18.13 network. Do you understand? So what happens if I have to send something to somebody else in my LAN? Well, the routing table handles that just fine. So let's take a look here. So here's 127.18.13.0. So basically here it says, anything for the 172.18.13 network. See the 0? It doesn't care what the last digit is. Don't send it on the gateway because you wouldn't want to, right? Because it's a local call. It's on link, and just send it out through the network card. That's it. So if we take a look, so if there's anything directly for 127.18.13.120, just send it to yourself. Okay, that's basically all it's saying. And then if you have to broadcast on the 172 network, 172.13.18.255, that one also goes out on the network card. Honestly, folks, those are the most important routes on any routing table. The trick that you run into is there's a few others in there. Let me just at least bring these to your attention so you know what they're there and why they're there. All right, so here we're going to see, I have just gone blank. This is for not unicast, not broadband, but I forgot what it's called. For the 224, it's like if I'm doing a video, I can set up a video player to be on 224. Basically, that's just a local call. And then these are just for broadcast. These are just for broadcast. Now, the metric just basically says if I have more than one route that goes the same place, I can have two routes. Network destination 000 netmask 127 da 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 da, and I could say interface. If I had a second NIC, for example, I could have another with a different NIC, maybe even a different gateway. But by putting different metric numbers in here, it tells the system which one I want to use. So this can happen a lot. It's particularly confusing when you have a system with two network cards. So what I'm going to try to do, I hope this works. I'm going to go back into my network. In fact, let me show you what I'm doing so you guys see what I'm doing. What I'm going to do is I'm going to light up the Wi-Fi here. So I'm just going to turn on the Wi-Fi, and I'm going to use one of my things in here, so it should get a connection. Bear with me just a minute. We're watching right here. I want to make sure it connects. Don't be trouble. Be good. Be for goodness. Okay, so we've now connected. All right, so what I'm going to do now, let me utilize this, and I'm going to do another route print, and we should see something a little bit different. And we do. Okay, so what's happened here is I have lit up a network card, and this network card is on a different network. So I can actually see right here, this network card, the wireless network card has an IP address of 192.168.1.78. The only thing that can be on interfaces are my network cards and my loopback, all right? So that's how I knew that automatically. So it's kind of interesting as you take a look, we have two default routes now. One says it's going to go out through my Ethernet, and the other one says it's going to go through my wireless. The only way you can tell which one's going to win is the metric. The smaller number wins. This is a big issue people run into all the time with multiple network cards. And it's usually a wired and a wireless. That tends to be the combination. And people get all confused because all of a sudden, if I type in www.google.com right now in my web browser, it's going to use the wired connection because Windows sets it up that way. The first good connection Windows finds, it tends to have that be the lowest metric. And then as others are added on, just as we saw right here, it goes ahead and gives us alternatives. But what it can drive people bonkers because you'll be working on a system and then all of a sudden your internet's down. And so you close the window, you close your browser, reopen the browser window, try again, assuming the other link is working, it will then automatically work for you. So, it can be very interesting. Routing tables teach us so much about our systems. It's absolutely critical that we're comfortable with different types of routing tables. So what I want to do now is see if I can do this without blowing anything up. So what I'm going to do now is I'm going to jump in on my home router and let's see if we can find the routing table for that and see if that makes any sense. All right, so this is a connection for my home router. You guys don't get all too excited. I change this stuff all the time. All right, so the WAN IP address, oh, that's the WAN side, not the LAN side. I want to be careful here. So I don't really remember where it is, but I'm looking. LAN? Route? Now I can add routes. I don't want to do that right now. I don't. What do you mean? I know exactly how to do this. What are you talking about? No. One moment, please. This is embarrassing. I think I may have been closer earlier. The reason, I'm pretty sure all I got to do is click this to show it. But I'm afraid to do it right now, folks, mainly because this is my connection to the outside world. And if I click on this, I'm nervous that I'm going to disconnect you guys. And then we have to do all this through interpretive dance, which I don't want to do. Oh, man, I could have swore that there was a nice, simple, easy... shouldn't be firewall, but let me double check. Darn it. Grr. All right, well, anyway, going back to this, let's make sure we can review a couple of things. Every device on Earth has a routing table, even individual hosts. So one of the things you got to remember is, number one, you're always going to have a default route. Always. Here in Windows, it's up at the top. On a lot of other operating systems, it's at the bottom. So be braced for that. So you're always going to have a destination, a net mask, some type of gateway, and then interface, and then metric. You're always going to have these 5 every single time. The other thing you're going to have is not only your default route, but then your local route. So the local route is here within my LAN. If it's in this particular case, it's 172.18.13. How do I send stuff around? So you will actually see on a lot of systems routing tables that are pretty simplistic. Especially a lot of times they'll dump all of the this kind of stuff and all of this. It's not that it isn't there. It's just that they don't feel it's super critical to show it. You can manipulate routing tables. It's actually fairly easy to do. And it's even more interesting. It's the same command both in Windows and in Linux. It's just basically route. You can do route add, don't want to lie to you. So I can do route add. As a matter of fact, here they got an example for it. Let me bring this up just so you guys can see this. So I can add a route add, da-da-da-da-da. There's my net mask. That's my gateway. And there's my metric. And then the interface is at the end. That's actually different than what you see in the order of the route print. They put interface last, which is kind of interesting. You can also remove routes. Adding and removing routes. Now, first of all, it's something you almost never do to a host. They don't do it. But to a router itself, if you're setting up a router, I need you to pay attention here, folks. If I have one router that spans 2 local area networks, okay? Most of the time when I set a router up like that, as long as I give the IP addresses, now remember it's a router, so it's like you have, let's say a 4, you would have like 2, 3, 4 network cards in there, and each network card would have an IP address. So let's start with a simple example where my router is simple. It only has 2 ports on it, and it's spanning 2 networks. In that particular case, the routers tend to set this stuff up automatically, and there's nothing for you to do. Usually what will happen is the router will see what's known as a local network, something that's physically connected to, because you named one of his port numbers, 192, 168, 4.10, that's part of that 4 network. And everything will automatically route. These are called static routes. And they're very important. It is the cornerstone of what makes most of the internet work. I know it's always fun to talk about BGP and OSPF and IS and all these other type of dynamic routing protocols. But the reality is that a huge percentage of the internet is set up on static routes. Well, what if they go out? Well, then somebody's got to go in there and fix them. But that's pretty much the cornerstone of it. All right, so that's the big question. I want to make sure we understand what a routing table does. The routing table literally tells the system what it's going to do with the packets that are going through it. Notice one of the other things important about a routing table, folks, is the routing table doesn't care where a packet comes from. So you can have a router with 6 ports in it, and all of the data packets can come in from any of those ports. But routing tables don't care what port it comes in. They only care what port it goes out. So that's kind of an important and a subtle difference. So let's see if we got any questions. That's all the basics I want to do on routers today. Why can't it's just frustrating to me that my little home router doesn't have. It probably does, but the moment I click it, I'm going to just knock everything down. I just don't want to do that. I'm looking one more time because I got to, because that's just who I am, because that's me. All right, frustrating, but I can't actually show you the net stat. I'm just trying to show you the routing table that's built into my router, and I can't see it. Grr. Oh, well. All right, well, let's see if we got any questions here for starters. Patricia, has the cat already moved in? Can you guys see a cat? Yeah, LB2 I call it. Trey Dilla, hey Mike, I'm taking the Net Plus on Saturday. Good luck. Well, Trey Dilla, I have every confidence that you'll be doing just fine on that exam. Good luck to you, man. All right. Steve G, hey Mike, Total Seminars. Have you seen the new Mario movie? I have not. Multicast. Oh my God, David. Thank you. Multicast. I just straight up forgot the word. Oh yeah, you guys got to see all my SSIDs. I've taken a lot of them out. All right, guys, so no questions, really? That easy. Look at me. All right. All right. Really, no questions. You guys understand routing tables that well. Okay, here we go. Quick, quiz time. Somebody type in the right answer. What command do I type in Windows to see my routing table? I am going blank. There's another way to, oh, R, that's it. Anybody type it in yet? It's route print. There you go. Okay, so the other thing you can use is you use a netstat command. Netstat minus R? Yeah. So you can run netstat minus R, and that will also show you the routing table on a Windows system. So pretty straightforward, pretty easy stuff. But routing tables are so important, man. Anytime things aren't going where they want, if I'm running IP configs that don't look pretty, or especially if I'm running pings, destination host unavailable, I'm definitely going to be looking at the routing table because, there you go, D Green even added that for me. Netstat minus R. Well done, sir. What is your opinion on the Netgear Nighthawk routers? They're fine. A little fragile, but, be nice to them. Don't let them get hot. It's about the only thing I got to say. But that would be true about almost any Netgear device. Netgear does not believe in paying enough money for cooling, in my opinion. All right, guys, so a couple of things then. That's going to go ahead and wrap up our discussion on routing tables today. We'll do a little bit more on routing tables next week. I just want to make sure everybody was cool with some of these basics. JD, hey Mike, being that the cloud has become so prominent, are you looking into creating a Cloud Plus course? JD, I am not. I am not, man. I have no problem with Cloud Plus. I think it's a nice little cert, but I am right now just maintaining what I got. So we got a lot of crazy stuff going on around here, so yes, not going to be doing it. Sorry, man. Guys, as Dave Rush has been kind enough to post in, you got my email address there, michaelm@totalsim.com, michaelm@nationalcyber.com. Feel free to contact me that way. Be sure to contact me on LinkedIn. Oh, you heard the kitty? Kitty! Kitty! Yeah, I don't know about this one. See, I want to take this cat and jack up the cat's collar, murder it, and then slide a new good cat underneath it. But for some reason, people have an issue with that. I'm just going to lightly kill it. It's no big deal. Guys, do be checking out our Discord channel. Those of you who have not met us on Discord, Dave Rush has placed a invitation in there for you. Please check out. The Discord is growing and blowing, and we need you over there. And even I'm showing up over there these days. So do check out the Discord channel. All right, so here we go. Here comes some questions. Will Shaw, Mike, How big a server rack should I get for my home build? I'm thinking 6U. Well, I think that's going to be more than you'll ever need. Unless you're really building some server boxes that you're going to leave in a rack in your home, I think 6U would be overkill. Honestly, I use home stuff that just screws to a wall, and I'm real happy with it. But I'm going to tell you, if you've got the space, Will, then go for it. In fact, I wouldn't even limit myself to 6U. I'd go for like one of these, half wall 24U things. The reason being, if you're going to go that route, then go ahead and let's put some proper DC power on there, leave some space for some servers. Just make sure you have air. This is the big thing that people run into with these home racks, is that you think you could drop it in some little closet and you put a couple of servers in there, you shut the door, and you come back and it's 93 degrees in your closet. So, it's no big deal, and it's a good idea if you can HVAC a little cool air in there. Or at the very least, put a vented door in if you're going to put it into a closet. But, look, the bottom line is 6Us, 9Us, 12Us. That's going to be plenty if you're just putting like one server in there and, a patch panel, a switch or two, a router on top of all that. But that's enough. Nigel Butt, is that a clapper in the background? It is. That's an original, the clapper. It doesn't work, but I love the box so much that I can't get rid of it. There you go. Andre's got a 9U. JD, understand, Mike. You've perfected A+, Net+. See all the work you put in. Yeah. Tolowit. How's the wait list been going? Tolowit, you're stalled. Let's get back on it together. Just so you guys know, Miss Wissa is moving in. Yeah, I've got a real roommate. So we're really hitting the dieting hard. We had a little fun last night because that was our swan song. But I'm doing 1,500 calories a day. So you might as well join me today. Do it. Nigel Blunt, I'm studying Core 1, 1101. So Nigel, when you type it like that, all the ones and zeros, like, is he trying to tell me something in binary? Off topic, is anybody wanting to do a revision session in Discord this week? I don't know what a revision session is, Nigel. Revision. I don't know what that is. Okay, so tomorrow in Discord, we got a 30-minute cram session on Core 1, followed by a 30-minute Q&A. Mike Meyers is next week. I'm doing something, I don't know what I'm... If there are any particular Network Plus topics that you guys would like me to hit on for me doing Network Plus on Discord next week, let me know what it is. I don't really have... I can talk about almost anything in detail. I'm toying with the idea of doing maybe a ports... port numbers and really understanding destination versus source port. I think that might be interesting. Does anybody else want to hear me talk about that? We could do something like that. But do keep in mind, we've got a lot of fun stuff. Oh, there you go, guys. You can go work that out. Have a study session. Excellent. So Nigel, you can do whatever you want here. It's all good, man. So my Net Plus session is Tuesday, May 9th. Okay, oof. That's coming up. New prescription for your glasses. All right, guys, it looks like things are quieting down. I'm going to go ahead and sign off for this week. We'll be back on next Monday. I'm definitely going to be seeing myself talking about networking, even here on the AMA. So keep in mind, we no longer have the Wednesday. This is it from going on, folks. Look for me more on Discord than here. But we will be, Mondays at 2 o'clock, we'll always be here, and it's just us, and we're always having fun. Patricia Grace, what? I never understand why people type question marks like that. I never understood what that means. Patricia Grace, I have a Wi-Fi analyzer on my phone that notes the 1/6/11 channel recognition does not apply to all circumstances. In congested neighborhood, one stand to benefit from not sticking to 1/6/11. That's true. Well, first of all, Patricia, there's just not a lot of people using 2.4 channel anymore. To me, the 2.4 channel is a backward compatibility channel that, like here in my house, I have 2 SSIDs running on the 2.4, and both of those are running there really because backward compatibility for a garage door opener that I have that does not run on 5 gigahertz, and I got a couple of old cameras that require the 2.4. But today, in 802.11ac kind of the universe we're in, 802.11az. Okay, thank you. I'm always, thank you for explaining that, Patricia. I was unsure. But, when it comes to the 2.4 band, of course, we have, here in the USA, we have 11 channels, right? 1 through 11. And, but the problem is these channels overlap dramatically. And so for decades now, we've always said there's really only 3 channels with 802.11 2.4 gigahertz, and that's channel 1, channel 6, and channel 11, because they're the only ones that don't totally overlap. However, a couple of things I'm going to say on that. Number one, you could put something on channel 5 and something on channel 6, and they work fine. Yes, there will be overlap. Yes, there will be some latency issues, but they're not dramatic. And the idea that you can only use 3 channels really isn't super accurate. There'll be some slowdown. But again, you're not going to be using the 2.4 band for anything hairy. You're going to be doing that all on your 5 gigahertz band. So who cares? Yeah, Andre, you're like me. Andre has garden lights. Yeah, there's always something like that in there. But yeah, don't be in a panic about doing that. If you really want to cheat, you can do groovy things. I'm not going to get into some of the crazier things you can do. All right. Yeah. So Patricia, the other thing you got to think, one of the things is that if you're having to support old stuff on a separate SSID, a lot of times you don't want that SSI to be blasting all over the place. Like I have one little SSID that points to my garage door opener, and that's actually piggybacking on my AT&T router that came in. Now my main router, the one I was trying to show you the routing table on there a minute ago, that particular router is set up towards the front of my house where I have a couple of cameras that it supports. But there are dead spots in my house where 2.4 doesn't work, and the answer is I don't need it anymore. So I don't worry about it that much. All right, guys, I'm out the door then. Folks, I will see you all next Monday. Until then, watch for me on Discord. This is your Uncle Mike saying bye-bye, and I'll talk to you guys next week. Hasta!